Uh, Good afternoon, friends. Good afternoon, students. Also, so there are some important questions. I am making this a special video for the icse 2024 batch. Chapter 1 I am making. So chapter 1, these are the some common questions that you can prepare. So now we are having, I will be going for some numericals. What are the types of numerical that can be seen in your exam? So that are the some important numericals that we are going to see. So what is the first numerical? That first numerical is this one. So here you can see the clearly that you have to find the position x. So here you have to find what is that position. What is that position? 10 centimeter, 20 centimeter, or what is it? So as you can see, it is a half meter scale, not a full meter scale. It is half meter scale. So to what is the main formula, principle of moments? That is, for a meter scale, whatever the force in that side, that force multiplied by the distance from the fulcrum, that is the moment, that is an anti-clockwise moment, should be equal to sum of the all moments of that side. That means clockwise moments. So that I have done over here. You can see it very clearly. That here you can see that is 10 gf, that is the force, and 30 minus x. Why? Each and every distance will be calculating from the fulcrum. So fulcrum 30 minus x. So 30 minus x is here equal to 10 gf here also, that side. So 10 into 50 minus 30. So I have made it like this. So from that, if you calculate, so you can find the x, what it will be the x, you can find it. Okay, so these are the questions you can have. Next, other type of question they will be asking whether this system is balanced or not. Is it balanced or not? So here you can see it is 4 into the 105. Why is this 4? 29 minus 25. So it is 4. So 4, that is equal to that side, that is 20 into 21. That means the distance between this 50 minus 29, that is 21. So if we calculate both sides, we are getting 420, and that's the reason why they are balanced. So in case if I get other numbers that like that in this section, if we get 420 in place of 420, we are getting 320. So that means 100 is the less over here, and that system will not be balanced. We need to add some amount of force over this side to make it balanced. Okay, which side it will be greater, that side it will be going on. Okay, now we will be going for the next one. So I have I'm going for the next. So what is that numerical? Now in that case, in the both cases, what we have found earlier, that weight of the scale is not needed to counter, or not needed to calculate. But here in case of this, we have to calculate the weight of the scale. So now you can see one is there at 20, then one is there at 80, and it is claimed that it is balanced at 60. Okay, that means it is a full meter scale. Okay, now sorry, in the place on 50 and 10. Okay, so here it is the 50 gf the force, and here is 10 gf, it is the force over here, and it is told that it is balanced and at balanced. And okay, so now we have to find what we need to find. We have to find what is the weight of the scale. Weight of scale. तो आपको स्केल का वेट फाइंड करना है. ओके, नाउ the one trick is that each and every time you have to calculate that the weight always acts to the middle. That means at 50, a total is 100, half is 50. So at 50, that weight of the scale is acting each and every time. If it is a half meter scale, then it will be 25. अगर half meter scale होगा तो ये 25 में सेट हो जाएगा. Now So now we are having two forces acting in this. So what should we do? What are the forces acting over here? Now 10, let me write it first, 10 into so here is that formula, 10 into 40. 40 is the distance between 60 and 20. So 10 into 40 plus W into 10 is equal to 50 into 20. So from there, if we calculate W, we will be getting 1000 minus 400, that is 600. 600 by 10, and that will be the 60 GF will be the weight of the scale. You can take it as GF, or you can if you want to take it in Newton, then also you have to go for you can also go for the Newton and all. So this will be the weight of the scale. So now another one we are having over here. This one earlier in some example or something like that you will have. Just remember one thing, we have to calculate the 10 Newton, and this is the distance from the fulcrum. That one is the F. That one is the F. So distance from the fulcrum. So what is it? So each and every one we will calculate. So now if we force this one to rotate like this, to force like this will try to rotate it in that direction. That means clockwise direction. So I will write all the clockwise one here and all the anti-clockwise one here. Okay. So all the clockwise one here and all the anti-clockwise one here. So what it will be? On the clockwise one, that means that 10, this will move here. This will try to move it like this. This will also, this will not try to move anywhere. So this 10 Newton, because the distance is 2 only, so unit will be Newton meter only, no problem. This 10 will it will try to move it anti-clockwise, so that I have written over here, and this will also I add up over here anti-clockwise. Anything behind this plane, behind this below this F plane, will be rotating it like this. So you can in exam, how you will know? Easily you can push your copy and you can know that you will be able to know in which direction. Suppose here, so if you push that force, it will be moving in that anti-clockwise direction. So you can easily see here also, if we move it is the plane, it is the original plane, and if we push any kind of force over here, it will move anti-clockwise direction. In that direction it will move. So here again anti-clockwise, again another one. So 10 into 2. So what is the clockwise? That is the 20 Newton meter. And what is that that will be 60 Newton meter. The total 60 Newton meter. So what will be the resultant? The resultant will be that the resultant force or net, resultant or net will be 60 minus 20, that is 40 Newton meter. Which one is greater? Now anti-clockwise is greater, so it will rotate, ultimately it will rotate anti-clockwise. So you have taken I have taken over 1 2 3 4 forces over here. So 5 forces are there. This force will not have any kind of effect because it is acting at the fulcrum to anything or axis of rotation or point of rotation. If any force is acting down that particular point of rotation or axis of rotation, it will not cause any kind of rotation of that. For example, if you just pull in the suppose this is the door, so it is door, so it is the particular about which it is rotating. So if you put any kind of force over here, the door will not open or door will not close. You have to put any kind of force over here on the door handles and all. So one question is there also, that door handles are provided near the edges like this. Why? Because to get you are getting lots of moment of force to rotate that one. So as longer as you can get that distance, then we will be getting longer moment of force. So okay, so these are the type of numericals which is widely given in previous years and all. So I hope you don't have any kind of doubt till now. Next, so I will be means coming another with another video for the chapter 2. Till then, take care, keep on reading, and thank you.